Hey students, welcome to a Mr. Panza Math online lesson answering the question, how do we create and apply number sentences? Let's take you through some charts to make sure that you understand how you can not only recognize number sentences, but then apply them to help you solve things like math word problems. First, let's start with the basic. What exactly is a number sentence? We did address this when we introduced some of the vocabulary, but let's dive in with a little bit more detail. A number sentence is nothing more than a sentence that has math stuff in it. It expresses a math truth by using numbers such as 3, 5, 100, and symbols or operations like the addition, subtraction, multiplication, or division symbol. You can also have a math sentence that uses symbols such as greater than and less than. It does not use words and punctuation marks. When you see word and punctuation, think about grammar. This is not grammar. This is math. So a math sentence is going to have numbers in it. It's going to have operations in it. It's going to have numbers, symbols, but it won't have words and punctuation. If a number has an equal sign, we can call that number sentence an equation. Typically, we are going to have equation number sentences because normally we will ask the students not only to create a number sentence, but also to solve it, which means if you're solving it, you need an equal symbol. Here are some examples of some number sentences. 2 plus 3 is a number sentence that tells us you can add 3 objects to 2 objects. 5 times 5 is a multiplication number sentence that tells us that when you have 5 groups with 5 things in each group, you have 25 altogether. A division number sentence tells us 12 divided by 2 is 12 objects being divided equally into 2 separate groups. Let's ask ourselves a couple of questions, because if you can understand a story problem, you can normally make a number sentence to match that story. And I like teaching this lesson before we get into any type of long or detailed word problems, because normally the last step of a word problem is creating a number sentence to help you solve a story problem. So let's take a look at a few simple story problems and then determine what number sentence would help us solve that question. For example, if Sam has 13 apps on her phone and Justin has twice as many apps as Sam, which number sentence shows us how many apps Justin has? So if I have a picture to represent Sam, I know that she would have 13 apps. In other words, Sam could get a bar picture, and that bar, I apologize for the squiggly lines, my mouse seems to be going haywire, would have 13 in it. But I also know that Justin is involved in this problem, and if he has twice as many apps, I'm not just going to have one bar to represent Justin, I'm going to have 2, and in both bars, Justin is going to have 13. So in reality, there's a couple different number sentences that could tell us how many Justin has. I could do repeated addition and say 13 plus 13 is going to get me the total for Justin. Or because I know that repeated addition is nothing more than multiplication, it's 13 times my total number of groups. Well, I have one group in this bar of 13 and a second group in this bar of 13. That gives me 2 total groups, which tells me I'm really just multiplying 13 times 2. Now, in reality, this doesn't seem all that difficult. You may ask yourself, why wouldn't you just add? Because when you get more and more groups, that's more and more repeated addition, and those are more opportunities where you can make mistakes. So instead, you should multiply. So the best number sentence out of A, B, or C that would help you solve this problem is clearly B, because 2 times 13 would get you 26. On top of the fact that there is no repeated addition 13 plus 13 as a choice, we know that multiplication is the best bet to answering this question. If you understand a story problem, you can make a number sentence to match that story. For example, if I have Chloe, Chloe has 16 cousins. So if I have Chloe and I represent her with a bar, I'm going to put the number 16 in there because she is one person and she has 16 total cousins. She's the one person that represents one group. However, John is the other person in this story problem, And he has 4 times as many cousins as Chloe does, which means that's not just one group. It's not just 2 groups or 3, but it is 4 groups of cousins. That would be in each group 16 cousins. This is why you want to know that I need to multiply instead of use repeated addition. Because if you used repeated addition, you would be adding 16 plus 16 plus 16 plus 16. And that's the number sentence that would get you your answer for Justin. We're looking for the easiest, simplest, and most efficient number sentence that's going to get us that same answer quicker. That's why they don't even give you an addition option. And that's why your eye should immediately go to 16 times 4, because the one number we are given, 16, is the total amount of cousins, and 4 is the total amount of groups that John has, because he has 4 more than Chloe. 1 group, 2 groups, 3 groups, and 4 groups. You determine the total number of groups by checking out the total number of bars, and you determine the total number of people or things within that group by seeing what the story problem is actually giving you. One more example. Understanding a story problem can help you make a number sentence to match that story. Now we have Chris. Chris has 1 bag of Skittles, or 1 bar. Here's Chris. He has a bag of Skittles, and it has 22 in them. Well, most times when you buy Skittles, they all have about the same amount of Skittles in them. So if Kelly has 3 times as many Skittles as Chris, that basically means she didn't just buy 1 bag of Skittles. She didn't just buy 2 bags of Skittles. She bought 3 total bags or groups of Skittles, and within the bag or the group of Skittles, we have 22 Skittles in each bag or group. So that's 22 plus 22 plus 22, and we know that repeated addition is nothing more than multiplication, which means out of these 3 choices, 22 times 3 equals 66 is the number sentence that would show me how many Skittles Kelly has. Moving on to a different concept, still talking about number sentences, but given 3 numbers, can we think back to fact families when we see 21, 3, and 7? And if we're asked to make 2 number sentences out of 21, 7, and 3, how do we do that? Well, when we thought about fact families, we would have our biggest number on top of the triangle and our smaller numbers on the bottom, and we'd also put operation symbols to help us create number sentences. This then tells us 3 times 7 is going to get us 21, or 7 times 3 would get us 21. This is the commutative property. Let me show you what I'm talking about. If you envision 5 as somebody who drives themselves to work, and number 4 also drives themselves to work, 5 times 4 will get you 20, which is an answer. At the same time, if number 4 was commuting to work, they could turn their car and move into the position of the 5, and the 5 could turn its car and move into the position of the 4. In other words, you could flip the 4 because it commuted or moved or drove to the position of the 5, and take the 5 and put it in the 4, and you are still going to get the same exact answer. This is the commutative property of multiplication. Regardless of which number comes first or second, you are still going to get the same product or answer to a multiplication problem. This 20 can also commute. This 20 can be moved all the way to the left of a number story problem. And you can say equals 4 times 5. And again, you could commute these and say, well, 20 is equal to 5 times 4. It doesn't matter where these 2 numbers are. As long as you're showing that 4 times 5 is 20, or 5 times 4 is 20, the commutative property will get you the same exact answer. Let's go back to our flip chart. In this case, we had to write 2 number sentences for 21, 3, and 7. Well, 3 times 7 is 21. 7 times 3 is 21. The same exact concept can be applied when you're talking about the 3 numbers 6, 24, and 4. 4 times 6 is 24, and 6 times 4 is 24. Another way you could write it, from left to right, you could start with the answer and still write two multiplication number sentences by saying 24 equals 4 times 6, or 24 equals 6 times 4. Try these on your own at home. Can you create two multiplication sentences using the numbers 40 and the number 8 and the number 5? Can you create two multiplication number sentences for the number 9, 7, and the number 63? And finally, can you create a number sentence for 6, the number 5, and the number 30? I encourage you to pause the video, try and create two number sentences for each of these, and then unpause it to see if you got the answers correct. I'm about to pop the answers right on the screen, so pause it right now. I hope you paused it because pop, here are the answers. For 40, 8, and 5, you can write two number sentences as follows. 8 times 5 equals 40, or 5 times 8 equals 40. For 9, 7, and 63, you could say 9 times 7 equals 63, or 7 times 9 equals 63. For 6, 5, and 30, it's 6 times 5 equals 30, or 5 times 6 equals 30. For each of these, the commutative property applies. 8 can commute to where the 5 is, as long as 5 is commuting to where the 8 is, which turns it into a completely different looking number sentence, which still gets me the same exact answer. 5 times 8 equals 40. Applying the same exact concept, you can write number sentences to match statements that involve word problems. For example, 6 friends, or 6 dogs, or $6 is 2 times as many as 3 friends, dogs, or dollars. Let's just pick dollars for the sake of this example. Can be written as $6 is equal to 2 times 3. You could also do $6 is equal to 3 times 2. Even though the number word problem is saying 2 times as many as 3, 3 times 2 is still going to get you $6 more. So can you try these three out by pausing the video and again seeing, can you make 24 is 3 times as many as 8? Can you make 50 is 5 times as many as 10? And 20 is 4 times as many as 5? Try it out and then unpause the video. But first, pause it right now. The answers when creating the number sentences would be first. 24 is what you're going to get, and that is equivalent to 3 times as many as 8. 50 is 5 times as many as 10. 20 is 4 times as many as 5. I want to point out a couple of key words. Is always equal. So you can see that each time I saw the is, I just transferred that into an equation, made it an equal sign. Times is always a multiplication symbol. So when you see Q words in word problems, change them to number sentences that make sense for math. So that's how you create and apply number sentences. Check out future videos for word problems because this skill is going to be critical when attempting to solve word problems. You need to create number sentences that will work. And these strategies that you learned in this video will be very helpful. We'll talk to you soon.